And Cath is an environmental marine biologist. She has research interests from the Mekong River in Vietnam and Cambodia to the polar regions. Her research group focuses on the impacts of climate change and plastics on marine ecosystems and animals, from small intertidal snails and worms in the Humber to mangroves and coral reefs in Asia and polar seabirds and seals. So pretty much everything, really. Her work has contributed to an assessment of the state of the Southern Ocean marine ecosystem, the implementation of a marine protected area in the South Orkney Islands, and has been cited in parliamentary debates. So please welcome Dr. Cath Waller.
Can you hear me? Yeah. Hello. So make great big claims there about doing everything. The problem with plastic pollution is that it is a global issue. So I'm going to take you a little bit from what Bob's talked about that's very local to more national and sort of regional things. And I don't want to, but I'm going to scare you perhaps a little bit to begin with some facts about what we know about plastics and what we know about plastics in the ocean. And perhaps more importantly, what we don't know about plastics in the oceans as well. So, just to give you an overview, the dark blue plot, the curved plot, this is showing how much plastic has been produced since the start of plastics in the 50s. So, in the 50s, early 50s, it's about 1.5 million tonnes of plastic. And if you add up what's been produced every year since then, we have produced about 7.8 billion tonnes of plastic since the 1950s. That's about 1 tonne per person that's living on it globally. 2017, it was about 380 million tonnes produced in 2017. When you look at things like plastic bottles, so single-use plastics, we produce about 20,000 per second, and there's 1 million plastic bottles sold every minute globally. And when you think about the time that this plastic is going to stay in the environment, these plastic bottles take about 450 years to decompose. So we're building up a massive problem in terms of how we're going to deal with the plastic we've already produced. We're never going to live without plastics. Plastic is too useful. I don't believe we'll ever see a world without plastics. Some plastics are less useful than others, and certainly the single-use plastics that are used for plastic bottles and food wrapping are something that I think is much more addressable than other sorts of plastics. Of these bottles that are produced, there's only about 7% that are actually recycled back into plastic bottles. So there's a lot of problems in terms of the circular economy and how things, are recycled. If we look at what happens to these plastics when they start getting into the marine environment, about 8 million tonnes per year of plastics gets into the marine environment. And primarily these are mismanaged plastics, so plastics that should have gone into landfill or that are somehow end up in the rivers, and then from the rivers end up in the oceans. And I think the thing that we've got to think about here is that there's quite a dichotomy between what we do in the developed world, where we have recycle bins and things like that, and what happens in other places in the world. So places like Asia, 8 of the 10 big polluting rivers are in Asia, and they don't have that infrastructure. So you're getting a lot of plastics that are coming out of the rivers and down into the surface of the ocean. Then you've got things that can happen like the interactions with the wildlife, whales, turtles, seabirds, so that you've got the potential for entanglement. And I work a lot with people on South Georgia, so we know that albatross who forage for massive distances, they are picking up plastics from the surface of the ocean, thinking the food and feeding them to the chicks, and you find dead chicks and the stomachs are just full of plastics, and you get all sorts. You get pen lids, all sorts of things you just wouldn't expect. We've known for quite a long time that the amount of plastic going in the ocean is nowhere near. We can't work out how much is getting sequestered into the deep. So Once these plastics get in the ocean, things grow on them, they get heavier and heavier, and they sink out down to the seabed. Also because the waves are moving them around, and they get broken down into smaller and smaller pieces. So there's lots and lots of problems. We estimate that there's about 3% of the plastics that get into the oceans that are floating around on the top. And when you think about things like the Great Pacific Garbage Patch, which is about three times the size of France, you know, that's a lot of plastic, but 97% of it is hidden, is sinking, and that's part of the problem. There's something like, it's been estimated that there are 5.25 trillion bits of plastic floating around in the ocean, and 80% of that is coming from the land. So there's a bit that comes from fishing and marine sources, but it's predominantly stuff that's being washed out and into the oceans from the land. So we know that it interacts with things on the surface of the ocean. We understand it starts sinking down through the water column. Things might eat it, things can interact with it, and it ends up on the ocean floor, a lot of it. So what do we know basically about what's happening with plastics? We know it's everywhere. So I work in the Antarctic. Well, the study I did found 100 times more plastics in the Southern Ocean than we could have predicted. We know that it's set to increase probably by 3 times the amount we're getting in the next 10 years. It's been found in the Marianas Trench, which is the deepest part of the ocean, so in Challenger Deep. That's about 11,000 metres down, so that's further down than Everest is up. We know there's been masses of stuff washed up in the middle of the Pacific Ocean. So there's an island called Henderson Island. It's in the middle of the Pacific. Nobody lives on it. There's about 38 million pieces of plastic on the beaches there. We know the garbage patches are getting bigger. That's basically what we know. We know we're putting a lot of plastic in, and it's doing stuff. It's floating around, it's sinking. What is less apparent, and what we know much less about, is what that is doing to the marine ecosystems. So what's happening to the animals? We've all seen the image on Attenborough's Blue Planet with the whale and the calf that they think might have died from ingesting plastic. But when you start looking at what's happening on a global scale in all of these complicated ecosystems, remembering that, you know, it should be called the Blue Planet, it should be called Planet Sea, Planet Ocean, not Planet Earth. We don't even really understand how long these things take to break down when they're on the surface. We don't understand how quickly they sink. We don't understand very much about what happens in terms of the chemicals they give off. So there's a little tiny bit of evidence now that suggests that these plastics, when they break down, they give off chemicals that are akin to some species of invertebrates, marine invertebrates and fish, to eat them. So basically the plastics taste nice. So there's a little bit of evidence to suggest that fish and corals for sure are preferentially eating them. We don't really understand about if they get into the seafloor and they get into the invertebrates, do the fish eat them? How does it work through the food chain? We have some evidence to suggest that krill, if they eat microplastics, these little tiny bits that are broken down into really small pieces, if they eat these microplastics, then they poop out even smaller bits. But we don't know whether that is going to affect how much they reproduce, whether or not it's going to affect how long they live. And krill, of course, I'm particularly fond of the Southern Ocean. It's where I do most of my research. You know, krill is the Duracell battery. It's the thing that feeds all the whales, all the seals, everything that we all like to look at, all the big charismatic animals. We've got some evidence that it is being transported down through the food chain, the pelagic food chain. So there are little invertebrates that live in this water column, and they make these sticky shells, little burrows that they float around in, and plastics stick to it, and they use these burrows, these sticky burrow shell nest thing, to filter feed out of. And they build them every day, each day they build a new one. These little things called sinkers are eaten by anglerfish, vampire squids, various different invertebrates, so that plastic would appear to be getting in through the food, into the food web there. And certainly some of the work that colleagues have done looking at fur seals in South Georgia, we found plastics in their poo. So they're certainly eating something that's ingesting plastic. It could be krill, it could be fish. And one of the things that I'm working on with a PhD student of mine is to try and work out how much of a problem this is, right through from the water and the sediments through to the big predators around South Georgia. So I don't really want to sort of leave on a doom and gloom note. Somebody saying, what are the solutions? I mean, I'm going to say something pretty obvious here. The obvious solution is don't let it get in the water in the first place. As I said, that's a two-pronged problem, I think. I think we can look at what we can do in our country, in Europe, and you know, the developed world. And then we've also got to think about what happens in countries that are still not at that level. I don't know if any of you have heard of the ocean clear-up big boom thing that's been floating around. It broke in testing. It's basically not being able to travel as fast as the plastic, so it's not going to work. So, and I'd also sort of say you're going to need a really big one of those to clean up the Pacific garbage patch. In terms of sort of more chemical things, there are bacteria now that we know that will dissolve and eat plastics, and scientists have taken an enzyme from this bacteria and they've actually mutated it, Doctor Who, and it makes it something like 50 times better, and it can break down plastic bottles in a relatively short space of time. So there are solutions, but I think that's what we need to do, and I think we need to sort of have a fundamental, perhaps change in mindset as to how we approach the use of plastics, because getting them out of the oceans is much more difficult than stopping them getting them in the first place.